Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to talk about how to make dilutions, and I'll do a couple of practice problems for you. So first, let's talk about how to make dilutions. When you're making dilutions, basically, as the name implies, you're diluting one more concentrated solution into a less concentrated solution by adding more of the solvent. Usually, again, that solvent is water, but not always. But you're adding more solvent to your given solution. Okay, so the way you do this is usually with something called a volumetric flask. And so I have a few examples of them. So we call these volumetric flasks. So here we have several different sizes of flasks, and they get smaller and larger. So I have got a 1,000 milliliter flask, and I've got a 500 milliliter flask, and this is, I believe, a 100 milliliter flask. I believe this is a 100 milliliter flask. It's not written down as far as I can tell, but they get smaller. You can have a 25 milliliter volumetric flask, 100 milliliters, 50 milliliters, or even larger. You can have a 500. You can have 1,000 or 2,000 milliliter volumetric flask. What I want to point out about these flasks and why they're called volumetric is basically because they only have one line that represents the volume of the flask. So in this flask, this is a, oh, there it is. I'm sorry, it's hard to see. This is a 250 milliliter volumetric flask. I was going to say that's pretty large for 100 milliliters. Um, so 250 milliliters. This flask can only measure 250 milliliters. It can't measure anything else. And so that's why it only has this one line. So if I could show you the one line there you could see the line right there. So that is the one line. And so when you add your volume to the flask, you have to make sure that the bottom of the meniscus is touching that line and it doesn't go over. You don't want the volume to be either below or above that line. Otherwise, you don't know what the volume is. The only way you know what the volume is if the bottom of the meniscus is on that line. So if you're below that line, you don't know what the volume is. If you are above that line, you don't know what the volume is. So the only way is that you need the bottom of the meniscus to be right on that line. Specifically, actually, you want the bottom of the meniscus to be touching the top of the line. Technically, that's how you know you have 250 milliliters of your solution. It's not a graduated cylinder or anything like that. So here, volumetric uh, volumetric apparatuses only have that one line. So you can have volumetric pipettes as well, where you don't get that one line. So that is contrary to what is something that is graduated. And so if you have a graduated apparatus, like a graduated cylinder or a graduated pipette, you'll notice that these are gradations. You can measure various kinds of volumes using this measuring apparatus. And so you can measure many different volumes as long as you're not over the top here. So if you're measuring within, you can measure any amount of volume within like 100 milliliters. This is a 100 milliliter graduated cylinder. But again, with something like this only measures one volume because it only has that one line that demarcates that volume. So this again is a 500 milliliter volumetric flask. So anytime you see the word volumetric in something, it just means it has only one line and it's made to measure only that volume. And these are pretty precise. So this measures to 2 decimal places if you measure it properly. So that is an introduction to the apparatus that you usually we're going to use when you do dilutions. Well, how do you do dilutions? Well, what you would do is if you're diluting a liquid solution, you would then take some of the solution, which is called a stock solution that you have. It's a higher concentration solution. And then you would take some of that and put it into the volumetric flask that you want for the volume that you are creating. So if I want to make a liter of this more dilute solution, then I better have a 1 liter volumetric flask. If I want to make 100 milliliters of this more dilute solution, then I will have a 100 milliliter flask. So this case, I have a 500 milliliter volumetric flask. So let's say I want to make 500 milliliters of a more dilute solution. Well, what I'm going to do is I'm going to take a measured amount of the stock solution, the one that's at a higher concentration, and put it into my 500 milliliter flask. And that's something I need to calculate out. Once I put it into the flask, all I'm going to do is add enough solvent, usually water, so that the volume will go up to the line. So I want to add my solvent up until the solution now reaches the line. Now, before I reach the line, I want to make sure I mix it up really well and make sure it's mixed up and mixed up really well. And then I'm going to then add it all the way up. And again, the bottom of the mist should be touching the top of this line. And so when you get to the top, you want to add really small amounts, like drop by drop, little by little, so that way you don't go over the line. Because again, if you go over the line, you got to start all over. You can't retake out the solvent. So if you go over the line, you're done. You have to start all over, and that's a waste of chemicals. So you don't really want to do that. So you got to be very careful. And that's how you make a diluted solution. So I have a picture here. So kind of express this mathematically. So here's my stock solution. Let's write stock solution underneath. So this is my stock solution. So here's my stock solution, higher concentration. I'm going to take some of this stock solution and I'm going to add it to an empty volumetric flask of the volume that I want to make, of the new diluted solution. So let's say this is 100 milliliters. So I'm taking a little bit and I put it in there. So this has a certain concentration. Let's call that M1 for molarity 1 for the first solution. So I'm going to take some of this first solution at a certain molarity. I'm going to put it into my empty flask. The molarity doesn't change. So I still have the same concentration here that I did here. Now that I have this amount here, the volume of the solution here is my V1. That's my starting volume. And we know that here, molarity of a substance is going to be equal to the moles divided by the volume, which is going to be in liters. So whatever the moles are, that's going to be divided by the volume, and that's my original, my M1. That's my molarity that I'm starting with for the stock solution. So this molarity is going to be moles divided by volume. And the V1 here is whatever I have here. That's my volume. So if I multiply the molarity that I have multiplied by the volume I have, that's going to give me a certain number of moles of my solute that's in here, right? So I have a certain number of moles of my solute based on this calculation. So the molarity of my original solution multiplied by the volume that I took out, that's the number of moles that I took out of my stock solution. So now I have a certain moles of my solute here. All I'm going to do is add water. So let me ask you this. If I add water to this volume of my solution that I have, am I going to change the number of moles of my solute? And the answer is no. Right? So no, I'm not adding any more solute to this. I'm not adding any more of my substance that I have dissolved in here. It stays the same. If this was a sodium chloride solution, and I have a certain number of moles of sodium chloride, I'm not going to add to my sodium chloride by adding water, right? All I'm doing is adding water. So the number of moles of my solute does not change when I'm adding water. When I'm doing a dilution, the number of moles does not change. All that changes is the volume. And as I'm adding volume, I'm diluting the solution. As I'm adding my as I'm adding my solvent, let's say it's water. If I'm adding water to this, the only thing that's changing is the volume. I'm not changing the moles. So when I change the volume, I'm diluting the concentration. So my concentration is going to go down. So I'm adding more volume. I'm adding water until it gets up to here. So this is what I'm doing here. So now I have a new solution, and we're going to call that M2. So the molarity of my solution is different now. So we call it M2. It's more dilute because the only thing I added was water. Now, here I can calculate the amount of moles in this solution. It would be the new molarity, whatever that is, multiplied by the new volume. So if this is a 100 milliliter volumetric flask, this is now 100 milliliters. And so that's my new volume, my new molarity. And so if I calculate that, that would give me my moles. But as I just said, the number of moles here is equal to the number of moles here. So the moles that I start with and the moles that I end with are exactly the same because all I did was dilute it. I didn't do anything, I just added more solvent. So if M1 multiplied by V1 is equal to moles 1, and M2 multiplied by V2 is equal to moles 2, and moles 1 and 2 are equal, then it follows that M1V1 is equal to M2V2. So that is why we can use this equation. So this is our dilution equation for whenever we want to figure out our dilutions. We can figure out concentrations. We can figure out how much of a stock solution I need in order to make a certain volume at a certain molarity that I want to use for other purposes. Okay, so that is how you make dilutions. Now I'm going to go over a couple of practice problems, so stay tuned. Okay, so here is a practice problem that is typical of dilution problems that you may be asked. All right, so let's get into this. So we have how much of a 2.3 molar solution do you have to use in order to make 750 milliliters of a 0.6 molar solution? Okay, so the first thing we want to do is recognize what we're getting our solution from and what we're diluting to. So the first thing we want to do is make sure you know your dilution equation. M1V1 equals M2V2. This is a dilution problem, so we want to use our dilution equation. The next thing we want to do is label everything that you know. So we're going to label these and find the missing part. So the first thing we want to recognize is how much of a 2.3 molar solution do you want to use? So this 2.3 molar solution is what we're going to start with. We want to make a dilution. We want this lower molarity, but we got to start with a higher molarity. So we have to recognize that this solution is our stock solution. This is the solution that we are beginning with. So that is going to be our M1. So M1 is 2.3 molar. 2.3 molar. Okay, so that's our M1. They're saying how much of this solution. So remember, when you're dealing with these problems and you're trying to figure out what they want, what are you trying to solve? What's your end goal here? It's usually probably almost 100% of the time the beginning of the question. So the beginning of the question is the end of your problem. So the beginning of the question is how much of a 2.3 molar solution. So how much of that we're talking about volume there. So we're talking about solution, we want to know what the volume is. So the starting volume, the V1, is going to be what we're looking for. So V1 is question mark. What is it? We don't know. That's what we try to find out. And in reality, this is what you would do in a lab, right? So I would use my V1, M1V1 equals M2V2 to calculate the amount of my stock solution that I need and in order to dilute to the volume that I want, right? So I need to calculate that. So what I need is my M2V2. So what's my target molarity? Well, my target molarity is 0.6 molar. So that's my M2. So my M2 is 0.6 molar. Okay. And then what's my target volume? That's the 750 milliliters. So my 750 milliliters. So that's going to be V2. So V2 is 750 milliliters. And so the only thing I don't know is V1. So that's what we're going to calculate. So we're going to plug everything into the equation. So my M1, oops. So my M1 is 2.3 molar, so 2.3 molar multiplied by V1, which is what we're looking for, is equal to M2, which is 0.6 molar, multiplied by V2, which is 750 milliliters. So 750 milliliters. Now, you'll notice that, well, Mr. Koval, why do you have milliliters there? We're dealing with molarity. Didn't you just say in a previous video that molarity is moles over liters? And so shouldn't we be multiplying this by liters? We need to change that to liters, Mr. Koval. What are you doing? I would say you're absolutely right. We should when we're multiplying by molarity. But in this case, it's special because when we solve for the new volume, we notice that when we divide this side, both sides by molarity, the molarities are going to cancel out, so it doesn't matter, right? So here's a little trick that you could use. It doesn't matter if you're solving for volume. It doesn't matter what unit you use, because in the end, molarity is going to cancel out, and you're going to end up with the same volume unit you started with. So especially in the lab, we're not going to be measuring liters of this stuff. Usually it's milliliters of this stuff that we want to measure, because everything that we're using is going to be pretty much measured down in the milliliters. Okay, so now we are going to solve this. So V1, if we divide both sides by 2.3 molar, V1 becomes 0.6 molar multiplied by 750 milliliters divided by 2.3 molar. So the molar cancels out and we're left with the unit milliliters. So when we calculate this out, we'll get milliliters, and my calculation is 195.65. 195.65 milliliters. So that is the number of milliliters of my stock solution, my original solution here, that I would need to measure out. And then what I would do is measure that out and put it into my volumetric flask. So if this is my volumetric flask, let's say this is 750 milliliters. I don't know if they make a 750 milliliter volumetric flask, but if they do, let's say this is it. I would measure out this volume using a graduated cylinder. Probably for this, I would probably need a 500 milliliter graduated cylinder. So I would measure this volume of my stock solution in the graduated cylinder, and then I would add it to my volumetric flask. This is my 750 milliliter volumetric flask. It's not really 700, it's 1,000, but let's pretend this is 750 milliliters. I would pour that into my flask, and then I would add water up until the bottom of the meniscus was at the top of the line, touching the top of that line there. And then once I have that water there, I now have my 750 milliliters of a 0.6 molar solution. And now I can go ahead and use this for whatever I need to use this for. One thing I do want to mention about problems like this is a lot of times they'll ask you, well, what volume of water should you add to the flask? And a lot of times, if we assume that volumes are additive, right? So if I have, what additive means is that the number of milliliters of one thing added to the number of milliliters of a different thing will add up to the volume of the total, right? So if I have 500 milliliters of water and I add 500 milliliters of this other solution, I would get 1,000 milliliters of the new solution, right? But volumes aren't always additive, meaning that you can add volume to volume, but you'll get a lower volume when they mix together. And that has to do with the fact that some particles kind of fit closer together, and so they'll fit in like filling in holes and things like that. And so you'll get a smaller volume than you would think, right? So I could add, say, for example, 50 milliliters of one substance to 50 milliliters of another substance. I would expect to get 100 milliliters if they're additive, but sometimes you might end up with 95 milliliters. So the volume is smaller than you would expect. And so because of that, in problems where they're asking you how much water is involved or how much water has to be added, they're assuming that volumes are additive, and then you would subtract out 195.65 milliliters. You would subtract that from 750 milliliters, and that supposedly is the amount of water that you add. But in the lab, you would never do that. Don't subtract the volume of your solution, your stock solution that you need to dilute, from your volume, your target volume, and then add that amount of water. That would not work, right? Because you're assuming volumes are additive, and a lot of times they're not. So what in a lab, what you would actually do is you would add the 195.65 milliliters of the solution, your stock solution, and then add enough water, whatever that is, just add enough water until the bottom of the meniscus is touching the top of the line, and then you stop, right? We don't, whatever volume of water that is, that's the volume of water that you're going to use. So it's probably going to be a little bit more water than what you would expect, right? So we're not going to measure water. We're not going to measure the difference in these and then use that volume of water to add, because it could be more, it could be less. So you don't want to risk going above that line. So that's the way you do it in a lab, right? So you're going to, again, add the stock solution that you need, and then just add enough water, whatever that is, add enough water until you get to until your meniscus gets to the top of the line, touches the top of the line. Okay, so that is really all I wanted to do in explanation of this video. I hope this was helpful in talking about how to make dilutions and how to solve problems with your M1V1 equals M2V2 equation. If you enjoyed this video, if you learned from this video, if this was interesting, then by all means, please like the video, share the video, hit that like button over there. Make sure you subscribe to my channel, and when you do, hit that notification bell, and then also click all after hitting the notification bell so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.